Hello, so today we're going to look at graphing the sine and cosine functions. So let's start with our unit circle that you can see here. And let's label it X and Y, label the axes. And let's remember what we learnt previously. We worked out in previous videos that any point along the where an angle intersects with the unit circle, so there's 4 that are marked here, I'll put dots on all of them for you. Any point along there, if we call the coordinates of that A or B, we worked out in the last video that they are also the cosine of theta and the sine of theta, okay? We're going to use that to plot the functions of sine and cosine. So first of all, let's put the coordinates in. So let me go ahead. So this one here is 1, 0. Up the top here, we have 0, 1. To the left here, we have -1, 0. And down the bottom, we have 0, -1. So, okay, now let's refresh our memory on radians. So we worked out we know that 360 degrees is equal to 2 pi radians. We also know that when we are finding a positive angle, it moves anti-clockwise around from this point here. So from the positive x-axis, we move anti-clockwise to get a positive angle. In the same logic, therefore, negative angles would therefore go clockwise. All right, negative, positive. Delete that. Okay. Now, so let's mark out. Oh, actually, let's quickly write out some conversions then. So if 360 degrees is 2 pi, that means 180 degrees would be pi because it's half of 2 pi. And then 90 degrees would again be half of 180. So that would be pi divided by 2 radians. And let me just write radians to be clear what we're doing here. Now, as you can see, our unit circle is broken up into quarters, degrees every 90 degrees, and we're going to do the same here. So let's work out the missing one here, which would be 270 degrees. How am I going to work that out? Well, 270 degrees is 3/4 of 160. So, let me jot this down the bottom so you can see. So 270 degrees, no, wrong thing. Let me try that again. So 360 degrees, oh my gosh. Let's delete that, sorry. 360 degrees times by 3/4 will give me the same as 2 pi multiplied by 3/4, okay? So if I want to find what 3/4 of a whole circle is in radians, I can just times 2 pi by 3/4, which gives me 6 pi over 4, which simplifies to 3 pi over 2. So 270 degrees is 3 pi over 2 radians. Now, let's also just go a little bit further. Let me rub this out. So if we were to find, so we know that 2 pi radians is all the way around, but what would it be if we went all the way around and another 90 degrees, okay? So 360 plus 90 is 450 degrees, okay? So what would that be? Well, we know that 90 degrees is pi over 2, and we know that 360 is 2 pi, so we can actually just go 2 pi plus pi over 2. There's other ways you could work this out, but we'll do it this way. Multiply that first, turn it into fraction to make it easier. Multiply the first fraction by 2, and you get 4 pi over 2 plus pi over 2. Now we've got the same denominator, we can add them, so you get 5 pi over 2. Okay. Another 90 degrees, so let's go around to here now. So that would make it 540 degrees. All right, this is an easier one because it's 360 plus 80. So it's 2 pi plus pi. okay, which 2 pi plus pi, which is 3 pi. So that's an easy one. All right, if we were to add another 90 degrees on there, we end up at 6. I'm going to do this wrong, aren't I? 630. Okay. So now you've got, if we go back, we've got 270 degrees plus 360. So we've got 2 pi plus 3 pi over 2. Multiply that first, turn them in fractions, multiply the first one by 2. So you get 4 pi over 2 plus 3 pi over 2, which gives me 7 pi over 2. All right. And then, of course, if we went all the way full circle, so 360 twice, we get 720 degrees, which is 2 pi plus 2 pi. All right, which is 4 pi radians. Okay. Now, let me quickly jot these up here so that I can delete everything I just wrote underneath. So 540 is equal to 3 pi. 630 degrees, we got 7 pi over 2. And 720 degrees is equal to 4 pi. So what we've worked out here is we've worked out the radians every 90 degrees in radians, going around the circle twice. Okay, and we've done that. I'll show you why we've done that. So now we're going to plot these, the radians along the x-axis, because the graph we're going to plot is y, the graph of y is equal to the sine of x. Okay, so this is x where we're going to plot our radians, and this is y. Now, along here, let's start. So if we go back and have a look, so actually we'll start at 90. This is going to be 0 at this point, okay? 0 radians. This point here is going to be pi over 2, and then pi radians, and then 3 pi over 2, and then 2 pi. So that's, we're up to 360 degrees now. So add another 90 degrees, we get 5 pi over 2, which you can see up in that corner. So 5 pi over 2, and then another 90 degrees gets us to 3 pi. Another 90 degrees gets us to 7 pi over 2, and 720 degrees, which is 2 full rotations, is 4 pi. Now we can also work backwards, and we'd have negative pi over 2, and then we'd have negative pi, and we'd have negative 3 pi over 2, and if I just extend it to here, let's do that so that we get negative 2 pi. Okay, so negative angles we'd get by moving this way. So there to there would be negative pi over, over 2 degrees. Negative pi over 2 radians, which I've drawn very badly. Okay. All right, so now let's plot this graph. So let's start, we'll plot cosine. So cosine is our x-coordinate. So I'll use purple. So at this point here, the x-coordinate is 1. So when x is 0 radians, y is 1. So that would go here. All right. Now we move to here. Oops, sorry. Okay, so we've moved now pi over 2 radians, and the cosine of theta is 0. So that's this point here. Now we go down here. So now we've moved pi radians around the circle, and the cosine of theta is negative 1. So that, I should have this marked as well as being 1, and down here is negative 1. All right, so that would be negative 1, and then we move around to here where we have 3 pi over 2 radians. We've gone, that's how big the angle is now, and we're down back at 0. Then if we move to here, we're back to 1. So 2 pi radians, and we're back to 1. And then it continues around. So hopefully you can see. So now Let me rub this out to make it a little bit clearer. So far we've gone all the way around. So now we're adding this on as well, another 90 degrees, which is what we did up here. So we're at 450 degrees, or 5 pi over 2 radians. And when we get back there, you can see this becomes a cyclical pattern. We're back at 0. Okay, and then at another 90 degrees around, so we get to 3 pi radians, we're back down at -1. And then we're back to 0 when we go another 90 degrees. And that is very badly written. Let me write that properly so that you can see it says 7 pi. Sorry, okay, and then 4 pi radians, which is completely around the circle twice, and we end up back at 1. So if I now sketch this, you will see what we actually end up with is a sinusoidal graph. That's what it's called, a sinusoidal. Okay, and it has this nice cyclical pattern. Now we can actually graph it into the negative as well. So if we go this way, let me rub these out. So we're moving this way now. So now we've got negative, where's it gone? Sorry, negative pi over 2. All right, and you can see when the cosine of theta is 0. Okay. And then up to here, the cosine of theta is -1. And then up to here, the cosine of theta is 0. And when it comes back to a full rotation, so it's gone -2 pi all the way around the circle, and it goes back to 1. So this graph also continues into the negatives. Okay? All right. Let's do the same thing now for sine, and you can see I've written the wrong thing here, which you might have noticed. So that what we just plotted in purple is the cosine of x. So y is equal to the cosine of x. Now I'm going to use green and plot y is equal to the sine of x. All right. So starting point. So at 0 degrees along this point, the sine of theta is our y coordinate. And it is 0. So at 0 degrees, it is 0. All right. Move pi over 2 radians. So I keep switching between radians and degrees. But we obviously are working with radians when we're talking about trigonometric functions. But sometimes it makes it clearer to understand if I refer to it in degrees. So I hope that's not confusing you. All right. So if we move 90 degrees, which is the same as pi over 2 radians, we get the sine of theta as being 1. All right, or the sine of x. They're used interchangeably. Different textbooks use different things. But I've written sine of x, so I should be saying sine of x. All right, now we move around to here. So that would be pi radians around. And the sine of x is 0. Around to here, where we're at 3 pi over 2 radians. And the sine of x is -1. And back to here, back to 2 pi radians around, and we're back at 0. All right, another pi over 2 radians gets us to 5 pi over 2 radians in total, and we're back at 1. Let's line this up. All right, and then you can see what's happening here. You can get another nice pattern happening here. All right. So you can see the cosine and the sine graphs are the same. They're just out of phase with each other. All right. So they're just pi over 2. They moved the pi over 2 radians off from each other. All right. We can do the same thing if we work backwards. Same thing again. All right. So if we move this down, going this way. So now I'm moving -pi over 2 radians. And the sine of theta is -1. All right, around to here, sine of theta, sine of x is 0. And then up to here, can't see it, sine of x is 1. All right, and then the sine of theta to here. So now we've moved -2 pi all the way around, and we're back at 0. So this one as well gives you this nice shape. Well, that was terrible. Try that again. All right, there should be a nice curve in this graph. All right, and that is our graph. There are graphs of the sine of x and the cosine of x.